Okay, so now we're going to finally talk about that strange symbol we've seen. Conditional probability. This is the probability of an event occurring once I know that something else has already happened. So given some sort of condition. And that symbol represents what's called that conditional probability. So it's, let's see, it's probability of event B occurring given that A has already occurred. And we look at it, the easier way to do that is to look at what's the probability that A and B both occurred divided by just the probability of A, the probability of the given. Now, some of the problems are going to switch the letters around on you, so you kind of just want to be aware of that probability of and over probability of given definition. In a recent study, it was found the probability that a randomly selected girl is 0.151 and is a girl and plays sports is 0.1. What's the probability? If the student is female, what's the probability that she plays sports? Okay, so let me kind of put it up there and we'll kind of talk about where they got these numbers from. So given that we're talking to a girl, I would like to know what the probability she plays sports is. Well, they phrased it in that conditional sense that if this condition happens, what's the likelihood of this other condition happening? So we look at and over given. Well, what's the likelihood, based on the numbers they gave us, that she's a girl and played sports? And that would be the 0.1. And then we would divide that by the likelihood of her just playing, of anyone just playing sports. I'm sorry, the likelihood of it just being a girl, and that's 0.51. So if I take those two numbers and divide, I end up with 0.196. Okay, another one, probability that a randomly selected student plays sports if they're male is 0.31. What's the probability that the student is male and plays sports if the probability they're male is 0.49? Okay, so we have to really think about what information they're giving us. Let me kind of put it up there so we can kind of see the change of the statements. So they told us the conditional probability. They told us that if they're male, I'm sorry, that if they're male, that they play sports is 0.31. And they told us the probability of being male. They want to know of someone playing sports and male, or the overlap between the two categories. So they kind of gave us some different information than they did before to essentially solve one of the few times we actually have to solve an equation. So in order to get this 0.1519, we want to multiply those two numbers together. Okay, so we're going to look at probability from a table. So we're given some data on, I guess, type of car and whether the car is European, American, or Asian, not the student, but whether the car is student or staff. And we're going to practice reading the table and finding the probability off the table. So what's the probability that the driver is a student? Well, how many total students are there? There are 195 out of 359. So that's the probability of being a student. What's the probability that a driver drives a European car? Okay, well, how many European cars are there? There are 45 out of the 359. What's the probability that the driver drives an American or Asian car? Well, how many Asian cars are there? And how many American cars are there? I guess stopping, are they disjoint? Well, not really, because you can't really be Asian and American. Well, people-wise, yes, but not car-wise. Anyway, so I want to add those two numbers up and divide that by the total 359. What about the probability that the driver is staff or drives an Asian car? Ooh, gotta be careful about this. Are these disjoint? Well, I can have a staff. I'm sorry, I can be staff and I can drive an Asian. Um, so there is a dependence of events there. So I want to start with the probability that someone's staff, which is 164, and the probability that someone's Asian, which is 102, and then I want to subtract off the overlap, which is the 47. All right, what's the probability that the driver is staff and drives an Asian car? Okay, so now we're looking at both staff and Asian, and that's just the 47. Okay, if the driver is a student, what is the probability that they drive an American car? Okay, this is conditional probability now because we have that if statement. So it's and over given. So I know they're a student. So how many students drive American cars? That's the 107. And then I want to divide that by the probability that they're just a student. So that'd be 107 over 195. Okay, probability the driver is a student if the driver drives a European car. Okay, again, we're looking at another conditional setup. So you got to first figure out student and European. I'm sorry, if they're, yeah, student and European would be the 33, but this time we're comparing it with European, so that would be just the 45. Okay. Management has determined that customers return 12% of the items assembled by an inexperienced employee, whereas 3% of the items assembled by experienced employees are returned. Due to turnover and absenteeism, inexperienced employees assemble 20% of the items. Construct a tree diagram for this event. Okay, so here is our raw data. Okay, hold on. I think I need to go back in and kind of help with this. Okay, so when we're setting up this tree diagram, we want to start with what types of decisions there are. Well, either an object came from an inexperienced employee or it came from a veteran, right? Well, we know there's 20% of inexperience, which means there's got to be 80% of the veterans. And on top of this, we also know probabilities for what percent gets returned from an inexperienced versus what percent gets returned from a veteran. So let me set up these probabilities here. Okay, so I know from the inexperienced, which is the 20%, that 12% get returned. Sorry, make my text box a little bit bigger. Which means 88% don't. And from the experienced, I get 3% get returned. I did not make these text boxes big enough. And which means 97% don't, or don't get returned. That's right. So that would be a tree diagram of our various scenarios that we could encounter. Okay, so going back to the question is what's the probability that an item is returned? Let me go to this fancy smancy little chart I made. I'll just try and copy paste. Oh, that worked. Okay. Well, let's take a look at all the different probabilities for where things are returned. Let me get a little chart that I can write in. Okay, so if an item was returned from an inexperienced person, that would be 0.2 times 0.12. And if it was returned from a veteran, that'd be 0.8 times 0.03. And then I want to divide that by the likelihood that just overall it was returned. And so let's see, that would be, let's see, we got the 12 and the 3%. I'm sorry, this is the likelihood that it was returned. Yeah, actually just this. I'm making up a conditional statement. I'm getting ahead of myself. It's the next part that's conditional. Oh goodness, I can't get this thing to come out. Okay, so if I type that in a calculator, 0.2 times 0.12 plus 0.8 times 0.03, I get that An item was returned about 4% of the, about 4.8%. Okay, this is the question I was trying to answer. Getting ahead of myself here. Okay, so if the probability, if an item was returned, what's the probability it came from an inexperienced person? So let's set up that fraction again. If it was returned, so I know it was returned. I know it comes from that 0.048%. That's the likelihood that anything was returned. What's the likelihood that it came just from an inexperienced person? Well, of this 0.048, inexperience just counts as the the 0.2 times the 0.12. That's the percent that came from just the inexperienced type. So I knew it was returned. I want to multiply that together. So that gives me 0.024 divided by 0.048. So if all the items returned, that works out to be 0.5. So I know half of them. If you tell me they were returned, I know half of the things that were returned came back from an inexperienced person.